All right, have you ever looked at a chart like this and just your eyes glazed over? It looks like a bunch of random dots and squiggles, right? Well, in the next few minutes, we're going to crack this code together. You're going to learn how to read what's called an ionogram, which is basically a weather map for radio waves. It's the key to figuring out how to send a signal clean across the planet. Let's jump in. So first things first, let's ask a really basic question. We all know the Earth is round. So how in the world does a radio signal, which travels in a straight line, get from, say, North America to Australia without just flying off into the blackness of space? The answer is actually pretty amazing. The signals bounce. Way, way up there in the atmosphere, there's this layer called the ionosphere. And under the right conditions, it acts like a giant, invisible, natural mirror reflecting those radio waves right back down to Earth. And the tool we use to actually see this invisible mirror, that's the ionogram. Seriously, the best way to think about it is as a weather map. But instead of showing rain or sun, it shows us the best highways for radio signals to travel huge distances. Okay, so before we can read the map, we need to understand the terrain, right? The ionosphere isn't just one big, simple mirror. Nope, it's actually made of a few different layers, and each one kind of has its own job. Let's do a quick meet and greet. Down at the bottom, you've got the D layer. It only shows up during the day, and it's basically a sponge that soaks up lower frequencies. A little higher up is the E layer, which is great for your shorter regional hops. Then there's the wild card, sporadic E. This one is totally unpredictable. It can just pop up and give you these incredible surprise long-distance connections. And then, at the very top, you have the F layer, which actually splits into two, F1 and F2, during the day. Now, of all those layers, the one you really need to care about for long-distance communication, what hams call DX, is the F2 layer. It's the highest, the most powerful, the most reliable reflector. Think of it as the MVP, the all-star player of the team. Okay, now that we know our way around the ionosphere, we just need to learn two key terms. Just two! These are the magic numbers that are going to help us unlock the whole language of the ionogram. This breaks it down perfectly. First, you've got the critical frequency, which we call faux F2. That's the absolute highest frequency that will bounce back if you shoot a signal straight up. It's a great way to check the health of the ionosphere right over your head. But we're not trying to talk to the sky, right? We're trying to talk to someone far away. So we send our signals at an angle. And that gives us the maximum usable frequency, or MUF. That's the best, highest frequency that you can use to bounce a signal over a long distance. The key thing to remember is the MUF is always going to be higher than the faux F2. So we know the layers and we know the key terms. You know what that means? It's time to put it all together. Let's actually look at our ionogram and read this radio weather map. First, don't get intimidated. Let's just get our bearings. It's a simple graph. The vertical line, the y-axis, that's just showing you the height in kilometers. The horizontal line on the bottom, the x-axis, that's the radio frequency in megahertz. And all those little dots, that's where the action is. That's where signals are actually reflecting. Reading this thing is actually a pretty straightforward 5-step deal. 1, you find those critical frequencies, like FO2, to see what's happening overhead. 2, you find the MUF, because that tells you your ceiling for long-distance chats. 3, you check the height of the F2 layer. Generally, the higher it is, the further your signal can hop. 4, you just look at the pattern of the dots themselves. And finally, 5, you put all that data together to pick the best frequency for what you want to do. And now for the most important bit, the so what? How do we take all this data from the chart and turn it into an actual practical decision? Let's put this new skill to work. You know what? It all boils down to this really simple rule of thumb. If you want to talk to someone relatively nearby, you're going to pick a frequency that is below the critical frequency, that FOF2 number. But if you want to go for the gold, if you want to reach someone on the other side of the planet, you'll want to pick a frequency just below the maximum usable frequency, the MUF. It really is that direct. And hey, don't worry if this feels like a lot at first. As the original source material puts it, with a bit of practice, an ionogram will tell you more about the fascinating dynamics of the ionosphere. It's a skill you build over time, and soon you'll be turning this complex-looking chart into a seriously powerful tool. It kind of makes you wonder, doesn't it? We've just learned how to read an invisible mirror in the sky that literally shapes how we communicate around the globe. So what other invisible forces are out there, quietly shaping our world every single day in ways we never even notice?